Saxon Algebra 2, Lesson 56. We're going to talk about angles and circles. This is a geometry lesson. It's painless. Don't worry. First of all, I want to talk to you about a circle. There's a circle. It has a center. It has a radius that is the distance from the circle to the edge all the way around. The radius is the same all the way around. My picture doesn't necessarily lend that impression, but it's true. What we're doing quite a bit now is we're talking about angles in circles. And we know that the measure of a central angle is the same as what we call the intercepted arc, right? This distance measured on the, I'm measuring on the outside of the circle, not floating out here in space, but I'm trying to make it distinct from this. This distance is exactly the same as that distance. This is called a central angle, right? We call this the minor arc, and we call all of this side, I'm making it squiggly to make it distinctive. Looks like a bad picture of a fried egg. This is called the major arc because it's bigger, okay? Minor arc, major arc. Okay, here comes, I'm just gonna toss a few more at you. A line that goes randomly through a circle, not through the middle, is called a secant. If you take a secant and trim off the ends of it, it's called a chord. And if you take a circle, go to the center, draw a radius to the edge, and then draw a line that's perpendicular to that. Okay, so this line meets this line at a right angle. That is called a tangent. Okay? Different from the kind of tangent that we talk about in trigonometry. Sine, cosine, and tangent, different kind of tangent. But a word that you need to know. All right? Now, we also have learned that there's something called an inscribed angle. It doesn't come out of the middle. It doesn't come out of a random point. It comes out of one edge of the circle and then it goes all the way across, right? And we know that if this is angle X, no matter what size it is what I'm saying, this will be 2 times that, right? Here we saw the amounts are the same. Here it doubles, all right? So inscribed angles are interesting and useful. One other picture John shows that I think is worth considering is that sometimes we have like overlappy inscribed angles. Like consider this. These are 2 different angles, right? But we know they have to be the same size because look, they both create the same angle on the arc, right? So we know these have to be the same size because they basically take the same bite out of the circle. That's how I always think of it, right? So if this number is the same, then this number also has to be related, right? This number would be half of this number, just like we saw here, right? But since they bite the same part of the circle, they must be the same. They must have the same teeth. I don't know. My metaphor just broke down. But that's an interesting thing to think about. And I think that shows up in some problems. So keep it in mind. All right, let's get into the algebra, shall we? I know, you're excited. It's the algebra of the geometry. Okay, let's start with a circle that has this situation going on. It's got a pair of chords crossing, and these angles, they're not going through the center. There's nothing fancy about them. We know that they're the same, right? They both have to be x degrees because this is a vertical angle. but we don't know how much they actually measure. So what we can do is if we can find out how much this measures, which John tells us very helpfully, and my picture doesn't look accurate to these numbers, but just work with me. If we know the intercepted arc, we can find the measure of that angle. Here's how we do it. X equals 40 plus 80 divided by 2. So that means this must be, I'm doing the math in my head, this angle X, both of them, are equal to 60 degrees. Oh, that's kind of a neat little trick, right? So vertical angles within a circle, we know the inscribed angles, we add them up, divide by 2. That gives us the measure of that angle. Okay, what about a different scenario? What if our lines don't cross inside the circle, but they're out here? Okay, so look at my lines now are crossing out here. The vertical angles aren't really going to help us, but there's something else we can do. We're going to call this angle in here, that's what we're going to call X in this example. And in this one, we've got this measure, which is 40 degrees, and then we've got this measure, which is 80. The numbers are the same as there, but that's just a coincidence. Don't let that mess with your head. Okay, so when the lines cross outside the circle, the angle creates 2 intercepted arcs, and what we do is we subtract. Instead of adding them, we subtract, and we find out that X is equal to 20 degrees. So this angle is 20 degrees. It's kind of interesting, right? All right, this one is quite similar. We've got 4 scenarios we're looking at here. This is the first one. This is the second one. This is the third one, which is quite similar. And then the fourth one is going to be a little bit of a mind bender. There always has to be a mind bender, right? What fun would it be if you finished a lesson and felt completely in control? Okay, this one was 2 secants, right? This one, oh, I guess these are all the same. I was thinking of something different. Never mind. It's okay. Oh, that's a really bad. Pretend that's a tangent. And then this one goes through. Okay? Same situation. If we want to find this angle right here, I'm going to call it X again. We take that and that. We have 2 intercepted arcs. And what are we calling them? 60 and 120. And this much. Right, we're trying to find the measure of this angle out here. Again, we say X equals 120 minus 60 over 2. 60 over 2, it's 30 degrees. All right, the numbers are not important. We're just looking at the angles that are made. The important thing here is that when the angle is created outside the circle, we subtract. When the angle is inside the circle, we add. Okay? And then the last scenario is when we have 2 tangents, right? This was 2 secants, this is a secant and a tangent, and now we're going to have 2 tangents, but the process, the math is exactly the same. Pretend they're perfect. I'm sorry that I'm not drawing them perfectly today. But this is 2 tangents. And again, we're trying to find this angle. Grace is on red alert. Clearly, the Huns are storming the gate. Okay, so we're still dealing with the same kind of thing. This is X. We want to know what's going on right there. We want to know the measure of that angle. We have 2 intercepted arcs, but what's cool is because these are tangents, between the 2 arcs, they eat the whole circle. It doesn't look like it because my picture is so flawed. But this is 100 from like there to there, And then this part is 260. Okay, because it's everything from that dot on. So the process is the same. 260 minus 100 divided by 2. That's how we'll get x. That's 130 divided by 2, and you get what? 65? No, I'm sorry. I did that math wrong in my head. 260 minus 100 is 160. 160 divided by 2 is 80 degrees. Sorry. All right, so inside the circle, outside, 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 2 secants, tangent and secant, 2 tangents. The process is exactly the same. So really, all 3 of these guys are the same, and this is the one that's different. That is what your homework looks like, or your practice, rather. Your practice, notice it follows the same pattern. Inside the circle, outside, 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 2 secants. Oh, these are both 2 secants, right? And then there's one that's a double tangent. Subtract, 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 add. All right? Now, the other part of this lesson, you don't have to pay any attention to, and I will tell you why. In this book, John begins, he thinks he's going to introduce you to the concept of proofs. And he's going to kind of ease you into it and give them to you, not so you actually have to work the proofs, but so you can see them and start to kind of wrap your head around them. I call foul. I think that's a terrible idea. I prefer to hold off on proofs until the beginning of your advanced mathematics year. So Laura, Vivian, and Jayla, what they're doing, that's the year when we'll actually start working some proofs, and we're going to start doing the easy ones first and not jump into the middle of these harder ones, which is what John's trying to convince me to do for you this year. So here's what I have to tell you. This part B will explain to you why this is true. This is what I just showed you. This part, I'm not going to tell you. Don't worry about it. Just trust John and me that this really is all legitimate. If you wake up screaming in the middle of the night because you just can't live with the uncertainty, there it is. There are the proofs that show why this is true, and you can read it for yourself if you feel the need. But otherwise, just know we're not ignoring proofs altogether. We're just waiting until your advanced year, and then we will tackle them properly. All right? That is the end of 56. Thank you. Good luck. Goodbye.